All right. Well, thank you for being here at the last session today. My name is Adolfo García Veytia. Usually I go by Puerco. I am one of the technical leads with Kubernetes release engineering. We work on the supply chain security features of the project, and also on the tooling that releases Kubernetes every month for you. I co-lead some of the technical initiatives in the OpenSF, such as OpenVex and Protobomb. And as of January this year, I started a new small startup called Carabiner Systems, with the focus on bridging the gaps on all of the technologies that we're going to be seeing today at play. So, first up, let's talk about supply chain transparency. So whenever you're consuming software, you usually are presented with a binary or a container image, and you think, well, should I run this or not? Because it can be insecure to just grab anything and run it in your system, so especially if you're in regulated environments and so on. And this is an important question because behind it, it masks a lot of other important questions that you need to ask about your software, and sometimes you don't have the necessary answers for it. And the problem is kind of composes because all of these questions also apply not only to the software that you have in hand, but also to all of the components that were used to build that software that you're considering running. So one of the things that we're trying to push forward to is having a transparent supply chain. That is, if you have an artifact, it should provide you all of the information to answer all of those important questions. But the important part is that that information needs to have certain properties so that you can trust it, right? It needs to be verifiable. You shouldn't be able to forge it. You should not be able to repudiate any of that data. And most importantly, it needs to be cryptographically linked to the artifact that you're running, so that there is a strong link between the data and the artifact. And probably you've been hearing this all day. This is what we commonly call an attestation. So what is an attestation? An attestation, you can think about it as a signed set of claims about the artifact that you have at hand. Or to quote Dr. Santiago Torres, who created the Intoro project, it's the little atoms of the transparent supply chain. And I really like this definition because when you think about it, you have attestations. The important part about the attestations is that all of the data that's contained in the predicate of the attestations is part of another format, mostly a standard or a well-known format that describes different aspects of your software. Obviously, the attestation, to be able to trust it, it needs to be signed. And the important part is that it has this atomic property because when you have a binary, all of those attestations come together to describe and have a rich load of data about the software that you're running. But now the important question is, I have all of this data, and now what? For years, we have been working on perfecting the generation and the definition of these formats, like SBOMs and attestations like Salsa and things like that. But now that you have all of that data that's starting to ship with the projects, what do you do with it? And this is what I'm presenting today. So I'm working on a new open source project called Ampel. Ampel in German means traffic light, and it's also an acronym in looking for a meaning, a backronym. So right now it's an amazing multipurpose policy engine, NL. So we're 80% L. And how does Ampel work? So when you have that piece of software that you're considering whether you should run or not, you have all of these attestations that ship with it or are at least locatable. And then the important thing is attestations have different kinds of data. Ampel has a policy, and the policy has certain rules, which we're going to explore. So Ampel has the capability of understanding deeply those predicates so that it can extract information and assess. It can work with any sort of JSON, but also has, as we'll see, features to understand deeply these formats. So based on the rules of the policy, it can tell you if those documents match your expectations so that you can block, and then the whole policy set passes or fails. Ampel is designed to be embeddable across the whole software development lifecycle, from pull requests all the way down to continuous verification on your workloads as they're running. But you can use it to gate builds, check on your builder images. So at least we're trying to do demos for each of those cases that you see on screen. There have been other efforts, but we think that Ampel has some powerful features that solve some of the problems that have been preventing to adopt others easy. So the first one is, as I mentioned, it's embeddable. We can reuse policies, as we'll explore in a little bit, and compose them in a more rich environment. We're building a community ecosystem of policies. Ampel can implement domain-based extensions and compatibility with the tools. So this is how we structure the policies. So at the core of a policy, we have what we call tenets. And those tenets are the principles that we believe are true in our information. So if you have an SBOM, a tenet is something that needs to be true inside of that SBOM. And these are the three main parts of the policies. There are more, but this is like the simplified version. So metadata about the policy, the version, the expiration date of the policy, because you want to renew them sometimes, the runtime, whether it's enforced or not, and the assertion mode, because when you have tenets, you can have force all of them to be true or just select some of them. Then you have the attester identity. Ampel supports natively Sigstore signatures. If you're familiar with the Sigstore project, it lets you sign without using keys. But you rather, instead of using a key as an identity, you use a workload identity, for example. But we can also use keys. And then the important part are the tenets. So each of the tenets, the tenets contained in the policy is one of the conditions that needs to be true about the information that you're testing against. So they have a few features. So the first one is tenets in policy support what we call attestation transformers. To give you an example of, well, the first one is the tenets contain the policy code and also the predicate types that you're testing against. So the policy code is the actual code that will be executed against the attestation data, and the predicate type is the selection of what kind of attestation you want to evaluate against. So the predicate type can be, give me an SBOM or a SAS attestation, an OpenEOX file, any of those. By default, Ampel ships with the cell runtime. This is an example testing against a Salsa VSA, for example. And this code ensures that the attestation marks the commit as passing and also meeting Salsa source level 4. And then the other is, you may be thinking, well, how do I find attestations? And Ampel supports has a growing number of attestation collectors. Right now, it ships with, it can read from the GitHub attestation store, from files, from JSON-L files, from Git notes, and OCI registries. And then some of the features include these attestation transformers. To give you an example, so for example, if you have an attestation containing an OSV vulnerability scan, and it says, okay, I have 5 vulnerabilities, but those are false positives, you can create OpenVex documents, create attestations of them, and then we have a transformer that matches all of those together and sort of mixes them and gives you and exposes to your evaluation engine the end result, which is the vulnerability scan with the false positive suppressed using the Vex information. The other one is it supports native plugins. So inside of the runtime environment, you can bring other libraries and tools that understand the data more in depth. So for example, Ampel ships with the Protobomb project. It's one of the projects that we maintain in the OpenSF, which is a universal I/O layer for SBOM data. So Protobomb can read any SBOM, regardless if it's SPDX or CycloneDX, and then exposes to your application, in this case to the policy engine, the raw SBOM data, so that you can work with one set of data regardless of the format. this is one of the examples of the runtime plugins that are implemented into Ampel. And finally, the tenets and the policies have the capability to be linked to existing framework controls. So if you're, for example, if you're instrumenting the CRA or FedRAMP or whatever, and you want to make sure that when you do the evaluation, you can match, I tested for this, so I think I'm complying with this, you can do that with the with Ampel. And then policies are the individual items, like the individual test units, but then they can be combined into policy sets. You usually will run a policy set against your artifact. So, for example, you can say things like, I want to make sure that before I release, my project doesn't have any vulnerabilities, has an SBOM matching certain properties, has a provenance attestation, and all of those are different policies that go into a policy set. So policy sets can be reference remote policies. So if you have a policy living in a repository, you can pull it into a policy set via HTTP or Git. And the important part is that by splitting the development of policies into like community, then we can create a policy. We have a policy repository with examples that you can reuse in your builds. And policies can be referenced remotely, which means when you run the evaluation, it will be pulled remotely, or we have a policy compiler that brings everything and generates a local file so that you don't have to be pulling things from remote locations. And we also have a tool called Policy Control that will look at your policies, compare against the latest versions and repositories, and bring the latest ones. Think about like a dependable kind of thing for policies. So as I mentioned, Ampel is designed to be there, to be embedded everywhere. And Ampel can be run in your command line. So it's just a binary that you download, and you can supply it. So you need to supply it 3 things: your policy, your attestations or attestation source, and the artifact that you're gonna test. In this example, at the very top, you have a binary called Hello Linux AMD. And below, you can see, if you were at the keynote this morning, where we presented the open source baseline from OpenSF, this is an example running some of the tests of the baseline against that binary. And this is like the output on the terminal. It can also run, and we have actions that are reusable. It can run on GitHub and test against either commits or artifacts, images, whatever. And it has the capability to output to the workflows like that. And finally, the results of the evaluation can also be extracted as another attestation, so that when you do all of those checks that you saw in the previous examples, and you just capture all of the results in a single attestation that has all of the data, so that you can go and perform an audit of the evidence that you use to evaluate your policy. And yeah, so basically that is it. Unfortunately, I don't have enough time to run like a full demo, but if anybody is interested, I'm happy to show it. And yeah, so the project is very, very new. So we just started it this year, and there's a couple of links to the repositories, the policy engine itself, the community policies repository, and the reusable actions that you can pull into your repositories to test some of this. And yeah, I think we can have, like 3 more minutes.
Yeah, we have enough time for a couple questions.
Yeah.
Good job. It's great. Let's start here.
Pergo looks awesome, man. On that last, the last attestation you showed, what's the difference between this and a VSA in your mind?
Yeah, so this is like a VSA, but I think of this one as a fully loaded VSA. So the VSA will tell you, okay, I'm matching this control, for example, like I'm meeting SALSA level 3. And this one, if you have, I don't think in this example, So this one doesn't show any matching to existing controls. But the difference between this one and the VSA is that the format that Ampel outputs has links and resource descriptors to reference all of the attestations that were used to do the evaluation. So one of the features that we want to add here is like also outputting VSAs. Once, if we get to generalize it, then we will be able to output this as a VSA.
Okay, anyone else? All right.
So, so I think you mentioned that it is embeddable. Like how easy is it to run without any external dependencies if you wanted to run it like in a bunch of other software that you already have?
What kind of dependencies?
Oh, like running it without internet access on a closed network.
So the only tricky thing would be the verification, but if you have the secure roots cached, then it should be able to run offline. And when I mentioned embeddable, for example, we have another project that can download binaries from GitHub repositories, and at the same time check, like think about like a curl that fetches down binaries from repos, that at the same time verifies policies. And that is like a whole other application, but we embed the whole policy engine inside of it, and then we can switch off some of the features that you may not need to a certain application.